Hi again. How's it going, guys? This is 6.3, so let's get right into it. These are confidence intervals on population proportions. It's your third type. The nice thing about these is you're going to use the Z distribution. So you're back to using the normal distribution in that table and everything. So a population proportion is the probability of success. We have these notations. So P is what we're using for the population proportion. You'll see that in the formula. And then Q is just 1 minus P, kind of similar to chapter 3. We also have P hat and Q hat. Okay, so here's where it starts getting kind of crazy. P hat is for a sample proportion, and then Q hat is 1 minus P hat. Okay, so P is for population, P hat is for sample. So in this number one, we want to just practice finding the P hat and Q hat. So P hat, you can almost think of that as a little formula itself. It's X divided by N. Let me make that a little cleaner. X divided by N. Okay. In other words, you're just finding the percentage of people in this case who said they prefer dogs over cats. 46 people preferred dogs out of 80, right? So it's just going to be 46 divided by 80. That's the P hat. It's just a sample proportion, 0.575. Q hat is just 1 minus that. So 1 minus 0.575 would be 0.425. Okay, so that's usually the first step in these problems, unless they're just giving you those values explicitly. Otherwise, the steps for creating your confidence interval are listed there. Some verifying that has to be done. You have to just verify that those are true. We'll do that in our problem. You're finding critical values. You have a new formula that you'll have to follow, and then you still do that add and subtract. You just add, subtract to the p hat. Okay, so number 2, survey of 80 students, 46 prefer dogs, construct that 95% confidence interval. Now I'm just going to follow those steps. So the first thing I got to do is find p hat, which we actually did above in number 1. That's 0.575. Q hat, 0.425. And I get better at my handwriting. Okay, that's step 1. 2 is just, you could almost sometimes just eye it. You just want to make sure that there is at least 5 people on either side. So just the fact that this is bigger than 5 means you're good. And also the people that don't prefer dogs is bigger than 5. As long as those are both at least 5, you've got it verified. Okay. Next, we've got to find the critical value. ZC. Remember, for that, just go back to your little table, the 95% confidence interval, back at the very beginning of this packet. You can just look that up. The 95% is the 1.96. Okay. And then finally, you're just going to plug numbers into this formula. I guess not finally, next. Plug numbers into this formula. So I'm looking at this formula right here, right? The E formula. Right? So I got a square root. And then I'm putting the P hat times the Q hat divided by the N. N is that bigger one, 80. Okay. So there we go. You could practice calculating that out. What you should end up with is about 0.108. Okay. And then now finally, add and subtract that to the p hat. So I'm gonna maybe just squeeze it in down here. I'm doing 0.575 plus or minus 0.108 to construct my interval. Okay. That's going to be 0.467 plus 0.108 is 0.683. And there's my interval. That's the final answer. Next, here's another one. Let's try this problem. We've got, again, first thing I want to do is find p hat. And that's going to be 1,422 out of 3,206. It's always the smaller number divided by the bigger one. If you're getting confused between x and n, your p-hats are never going to be bigger than 1. 4. This one goes on a while, so I'm just going to carry it out to 4 decimal places just to be certain that I get something accurate. Q hat is 1 minus what I just found. .5565. Okay, and then I'm back to my formula. Oh, here we have a 99% confidence interval. I forgot that. I got to get the z. That's that one. That's 2.576. So 2.576, and then the big square root piece, 0.4435, 5565. Just follow along that formula, and then divided by the n, that big number, 3206. Okay. So let's calculate that together and see if we agree. This is going to be about 0.023. Okay. And then add and subtract that to your p hat. So now I'm doing 0.4435 plus or minus 0.023 to get my final answer. And I might just go 3 decimal places for the ends. This is about 0.421. And then .467. Close enough. All right. Okie dokie. That's about it for this section as far as the confidence intervals construction goes. There's some minimum sample size problems, which I'll do in a minute. But let's real quick jump to StatCrunch. There is that StatCrunch shortcut, of course, in all of these. So I'm just going to redo those 2 problems and just showing you the StatCrunch way. So let me go over to desktop. And I'll bring up good old StatCrunch. There's the table. Okay. So we're going here. This one's located under stat, proportion stats, 1 sample with summary. Okay, there's your location for this. So stats, proportion stats, 1 sample with summary. It wants those number of successes and number of observations. So number of successes in that first one was 46. Number of observations is 80. So number of observations is n. And then just do confidence 95. Don't worry about the method. We're always just doing this standard walled method, but don't change that at all. Okay, so that's all you gotta do. And then we can double check. All right, 4, 6, 7, 6, 8, 3. Cool, that's what we got when we did it by hand. Okay, let's try the other one. Stat, proportion stat. One sample with some. Number of successes on that one, 14.2. Number of observations, 3206. Level of confidence on that one, what we do to 99, didn't we? And then compute. 421, 466. Okay, 466, 467. You know why that one's going to be a little different is because we had some rounding error probably when we did it by hand. Because our p-hat wasn't like a perfect decimal. It kind of went on for a while, right? But that's how the StatCrunch works. So I'm feeling pretty good about that. We could practice a little bit more. One other thing is just, the interpretation of these. So interpretation, when you create that confidence interval like this first one, think of these as percentages, right? So we've got this, this one here. Think of that as like 46.7% and 68.3%. So we are 95% confident that the true population proportion, so the true percentage of students at ARC who prefer dogs, is somewhere between 47% and 68%. Okay. This is the kind of confidence intervals you see in the media, especially during times of, or when, there's like elections, and they say, hey, 52% of the population thinks this person is going to win. There's always that little margin of error that's given, like a plus or minus 2%. That's what we're talking about here. Okie dokie, that's it for now. I'll finish this packet off in one more video. It'll be a short one with that minimum sample size. Okay, that's it for now. Thanks for listening. Talk to you later.